Presentation will go for about 45 to 50 minutes, and it's going to be an overview of 5 key products that relate to construction workflows. So the agenda in terms of software is going to cover a quick overview of Revit and how you can develop Revit models for construction purposes. Navisworks, so this will be Navisworks Simulate and Navisworks Manage, and now it can be used for construction logistics. Then our new point layout tool, which works with both Navisworks and Revit for doing survey setouts. Then BIM 360 Glue, which is kind of like Navisworks on the cloud, which allows you to do clash detection, but also allows you to view the models from your authoring software on mobile devices like iPads. And then finally, we'll finish up with an overview of BIM 360 Field and how this can be used on site, how the BIM data can be leveraged and then used by contractors and subcontractors and even building owners to manage their facilities. So the summary of this presentation, it's about increasing efficiency, improving profitability, and reducing risk with the information for construction. So we're going to learn about the tools such as Revit, Navisworks, Glue and Field, and Point Layout can be used to streamline the workflows, turning design into reality. So hopefully by the end of this, this is a very short presentation, but you'll be able to get a broad understanding of how the tool sets are available to facilitate the use of models in the building phase of a project, understand how some of these workflows could help streamline your building processes, and then consider some new opportunities on how to utilize that authoring model in your building workflows. A bit about myself, just before we get started. My background is actually architecture, but I worked in the UK for around about 10 years where there was a lot of design and build workflows. So from day one, you were sitting at a table with the contractor designing a building to work well for the contractor's workflows. I did this for 10 years, and I've been at Autodesk now for 4 years. But I was involved with a number of building projects across Australia, New Zealand, and Europe, and also the Middle East, where there was a lot of oil money for doing larger developments. So, to give you an idea of where Autodesk are going with the Revit or the BIM data, we've got a number of tools that allow you to do planning, like master planning with our Civil 3D applications and InfraWorks. We can develop our building designs within Revit and our AutoCAD-based environments. And then for our building workflows, what we're doing is we're using that data to allow better constructability. You can do estimations using the quantification tools, clash detection to do coordination. So for a heavily serviced building, it's a crucial tool to have clash detection to coordinate all the services running in the ceilings. Working out our on-site planning and logistics, we have Navisworks Simulate, which allows us to link in Gantt charts to drive sequences of building components. We have a couple of new applications in Autodesk now. One is advanced steel and map fabrication. This is the MEP fabrication, CAD-CAM, CAD-TUC tools, which allow us to leverage Revit data and take it straight out to the CAD-CAM machines. And then finally, we have the field execution. This is our BIM 360 Glue and Field tools, which allow you to be on site with that BIM data on a mobile device, going through issues and tasks and checklists. And then finally, with that as-built model, we can hand it over to the building owner for them to run that facility. So this is a quick snapshot of the Autodesk wheel explaining where we're going in the stages of buildings. So the idea in the virtual model as opposed to building it twice in the real world. So this is a quick snapshot from Modern Construction. It's a Navisworks model of a heavily serviced building. And you can see on the left there, the Navisworks model is pretty close to the as-built model. But what large construction companies are doing is they're using the Navisworks model. They're working at every single component. They're revising and working out all the clashes before they get onto site, before they get onto having issues on site, which of course are expensive to rectify. So some case studies I put together in the past. This is one of BAM Construction, a big UK construction company, where they've gone through the build it twice scenario, building the models in the virtual world, so they only need to solve it once in the real world. Having tools for coordination like clash detection is saving a huge amount of money, over £500,000 in savings. Of course, a lot of less redesign work, so 30% savings in that space. And a huge one when it comes to time, saving 15,000 team hours on site. So also being able to run those virtual meetings with all the collaborators being able to get into an application like BIM 360 Glue, you can run these virtual meetings on the cloud, and it's saved over 60,000 miles of travel. So another reason why to be able to use these cloud technologies to collaborate and coordinate models before you go out to the site. Another case study here is with Skanska. So they do a lot of healthcare projects. And in this case, BIM was used to optimize the design process. So in healthcare, they're heavily serviced, but there's also a lot of standardization and repetition. So in this case, for the single bed wards in this healthcare project, a lot of the build of these wards were done out in the factory. So you can see here, this is where they did the bathroom pods for this design. It was actually done in a prefabricated conditions. So what this means, we used to do a lot of standardization and repetition, is you can build this offsite in a factory, which means you're going to be able to accelerate your construction schedule. It's not going to be as difficult to build it on site. It's going to be a lot quicker and easier to build it in factory controlled conditions. The productivity is going to increase. The quality is going to be much higher. And also, when we talk about things like lean construction, there's going to be reduced waste. So it's a lot more sustainable to build it in a factory floor than it is to be trying to do stuff on site. And of course, one of the key things in construction is worker safety. So health and safety ticks all the boxes when you're trying to do more in factory control conditions as opposed to on a dangerous construction site. This is a case study on BIM 360 field efficiency. So Skanska's been using this on a university project, and you can see the savings here for project managers, superintendents, and project engineers. On the right-hand side of the screen is a little graph just showing the time saved for different people working on this project. And you can see on the left, it was taking over 56 hours to deliver a number of tasks, and then by using BIM 360 Field, which was formerly called Valor Systems, the users are saving over 9 hours per person per week. So there's quite a significant efficiency gain by using these tablets, using these BIM 360 Field tools on the site. Okay, so with the case studies finished, I want to move into our construction solutions and how some of these solutions could be of interest to yourselves to help with productivity, quality, and efficiency. So we're going to start off looking at our authoring building information tool. So it's an information-rich model. It has a lot of data embedded within the components, within the families. You can use this information right through from conceptual design to operation, and I'll show how the data from BIM 360 Field comes back into the Revit model. It's a single point of change, so all the data can be contained for the structural engineers, the mechanical engineers, the fire engineers, the architects. All this data can be within the single coordinated model. It's coordinated documentation as well, so as you change one item in the model, it updates in a number of other views, and it's also a very sustainable way to design. The great thing about this application is it increases productivity. We hear a lot from our users that it's brilliant to extract out construction drawings. There's less risk of having errors in those drawings in terms of coordination. There's a lot more offering on deliverables, so when we're moving into, say, fabrication and facilities management, the authors of these models can provide more data within them that can be used for facilities management and also fabrication and CNC machines. Excellent communication, so more stakeholders in the project aren't just looking at plans, sections, elevations. They can get inside the model, they can walk through the model. You can run different types of analysis within that model as well, things like computational fluid dynamics. And of course, with the visualization tools and better communication and collaboration, you're going to be able to win more business. So it's a great way for a number of stakeholders to bring in more work to their company. Within our Navisworks applications, we have which sit within the suites. So we have our Building Design Suite Premium, where our users will have Navisworks Simulate. And this is where you can do construction logistics using our Timeliner tool. And then within the Building Design Suite Ultimate, this moves up to Navisworks Manage. And the difference here is you get clash detection. So you get all the tools you get in Simulate, but the main thing in Manage is you'll get clash detection. And this will help with reviewing the model in the virtual world before you get out on site. You can buy these all separately outside of the suites. However, usually when you buy the programs inside the suites, you get pretty good value for money. So we can run design review, 3D coordination, 4D planning, which is our logistics, quantity takeoff, and visualization. You can do rendering on the cloud from Navisworks, all within the Navisworks Simulate. And then when you move up to the Navisworks Manage, you get the clash detection feature, which will go through your model and highlight all the different errors that could exist in it before you go out to site. Some great benefits here in terms of streamlining the workflows, increasing efficiency. A lot of associates or people at director levels who may not be interested in the authoring tools like Revit can get up to speed very quickly with Navisworks and understand the complications of that design model. It's very quick to convey design intent. It's definitely going to help you improve your site logistics and workflow planning, because you can link in your Gantt charts, a CSV file or a file from Primavera, for example, and there's less rework and wastage. So again, this is going into that lean construction bracket. The next evolution of Navisworks is our BIM 360 Glue application. So this is real-time collaboration. It's cloud-based, so you can run it from any type of computer. You can even read the information on an iPad. It can be read from any time or anywhere as long as you've got an internet connection. You have some of the tools that have come from Navisworks. We have design review, where you can do your markups, walk around the model, take measurements, and interrogate the properties inside of those model components. There's 3D coordination and clash detection as well. So on the web browser interface, you can run a clash detection of all the parts in your model, and it works on mobile applications. So you can view that same cloud model from an iPad device, and you can be on site reading that information. So the great thing, more stakeholders are going to be able to get online and access the model and contribute. It's going to give everybody better project insight with up-to-date single project views. So instead of having to download the models and have them saved on a network or on someone's computer and then uploading and re-downloading, it's all in the one location. So everybody can get the latest activity feed from that one model. And this is going to improve project delivery with less requests for information, and it's going to be much better for coordination. So again, we're resolving conflicts prior to getting out on site. We're doing this in the virtual world before going out on site and having to deal with expensive problems. Finally, we have our BIM 360 field application. Again, these are just overviews. We're going to get into a bit of a deeper dive in a second. This is where we can use it for our construction field management. commissioning of equipment. So if you've got equipment in the plant and you need to start stuff up, you can track all this information, even things like warranties and lifespans of that equipment. And then finally, handover. And this is where we're moving into the facilities management and operations and maintenance of that building. So there's a lot of this information that can be captured during the building stage, and then you can actually take that as-built information and populate it back into a Revit model or a Navisworks model or even into parts of the glue model that can be used for your facilities management operations. So all that project documentation can be accessed via an iPad. You can access it on site. It's going to improve your QA, QC, and safety processes. It's going to be incredibly streamlined because the data from your Revit model is going to be able to work with the commissioning setup. And for a master contractor, a main contractor, looking at all the different subcontractors working out in the field, we've got dashboard reporting so they can see which contractors or which subcontractors are ahead on their tasks or behind, or how many issues are open or items that need to be ready for inspection. Again, this is fantastic, like in the Skanska report, it's saving users a lot of time, so you're going to increase efficiency. It's got proactive tracking of quality, safety and commissioning issues. It's going to improve governance and centralized streamlined processes. And the key thing here is you're going to save a huge amount of time, almost a day of time on site. You're going to reduce duplications because everything's going to be within the one location that everybody can get access to, and it's an automated collection of project data hosted on the cloud. Finally, here we have point layout, and again, this is leveraging the BIM data. So this is a Revit model. It could be done within Revit or Navisworks, where you can assign set out points to the model. You can export those data to a total station either via a USB or even via BIM 360 field, and then you can re-import the as-built information and run analysis for point cloud deviation. So in this case, what's been shown on the screen here is the surface of a slab and the deviation over that slab. You can record that information out on the site, bring it back, integrate it via BIM 360 field, and then bring it back into your Revit model and check the as-built against the design. It's fast, incredibly accurate for setting out. It's going to improve your QA, QC process, reduce rework, and of course you're going to be able to check that as-built component, as-built building against the design model. Okay, so I'm going to kick into some workflows now. We're at 20 past, so we're on time. So this is a data set. I'm going to try and keep some consistency here with this one data set, which has been developed using Revit, but also there's been some workflows with advanced steel. So this is where you can actually populate all your connection details by taking your Revit model into advanced steel and automatically make connection details. And part of the model also contains Inventor. So for anybody working in the manufacturing area using tools like Inventor, a lot of this data can go into Revit and be used downstream on the field as well. So we're going to look at constructability. How do we take this data and then use it for construction workflows? So the first workflow I want to kick off with is being able to work with the Revit model. So you've been handed over a Revit model and you want to gear it up for construction workflows. So what we can do is we can use some of the new tools like Divide and Parts, which came out in Autodesk Revit 2014, and we can take it into to Navisworks for simulation purposes, looking at construction logistics. So a workflow here that we're showing on the screen is a floor plan looking at a slab. And with that floor plan selected, we can go to our Divide Parts tools and actually break that slab up into, say, precast concrete components. Or maybe it could be for slab pours, depending on the construction workflow. So what we can do is we can sketch out the breakups of those slabs, or we can start to use some of the line work that exists within that Revit model. So in this case, what we can do is we can select the grid lines and we can instantly create breaks within those slabs. So we select it, we finish the command, and then before we complete the command, we can also add gaps and division profiles. So this is a very basic example, but what you can do is you can create your own division profile to show how those slabs come together. You can mirror the division profiles, and you can add gaps and offsets to create that slab component that you want. So a lot of this can be customized to suit your preferred workflow with precast concrete flat slabs or in situ slabs and pour sequences. So with that finished, we can conclude that command, and then what we have in our model here is all the slabs broken up based on those grid lines. Now in this case, this is just a basic tutorial, so you probably wouldn't do it exactly like this, but that's how easy it is to take a Revit design model and then break it up for that construction workflow. In this case, we can turn on the parts. So in our properties, we can turn on show parts, and then there's other tools we can use like displaced elements to pull that model around for better visualization purposes. So one of the simple tools we have within Revit is this displaced parts tool. So with part of your model selected, this is just a very basic view, but maybe you want to use this for, say, construction assembly details. So you want to have a sequence of installation events. This is where this type of tool could come into play. So with the items selected in the model, we can select on this displaced elements feature in the view tab there, and we can start to pull apart the displacement sets. What it doesn't do is it doesn't affect the main model. So you can duplicate a 3D view, or you can crop a sectional view, and it won't affect the main model when you initiate displaced parts. So here we have different graphic display views as well. So sometimes you need to see through walls, or you want to adjust the projection lines or cut lines. This can all be customized within the Revit interface. And we can also add these path lines. So these are the dashed lines going back to the origin point of the model. So every time you pull this model apart and you have dashed lines going back to its origin, if you move those model elements from point A to point B, it will still show the dashed lines going back to the correct origin point. It will follow that object around the model. So it's a very simple, easy tool to use, and this could play a good part in terms of doing construction assembly visualization for certain detailed components in your model. So moving into coordination, this is Navisworks Simulate. So for those of you who have the Building Design Suite Premiums, you have access to Navisworks Simulate. For those of you who have Building Design Ultimates, you'll have the Manage for clash detection, which we'll come to in a minute. I also want to talk about BIM 360 Glue here as well, because you can publish your data directly from Revit, or you can publish the data directly from Navisworks. You can get the add-in here and publish it directly to the cloud. With Revit, you can publish it as separate models, and then you can merge them together on the cloud, or Navisworks, you can merge them all together on Navisworks and then publish them to the cloud as one merged model. What's interesting with Navisworks is it holds all the material data as well, so when you're up there on the cloud, you can actually see all the material textures transfer through. And finally, I'm just going to do a few quick snapshots of Glue and how it's used for navigating and doing reviews of the model, and also clash detection. So I will be using PowerPoint slides for this because it's a webinar. Whenever we try and do videos, there's a bit of a lag, so we're just going through step-by-step PowerPoint. So inside of Revit, when you get the Glue add-in, this actually comes with the 2015 version. You can glue it directly to the cloud. There's other things you can do where you can do clash pinpoint. This is like a Navisworks Manage where you want to use switchback, so going from the clash detection back to the authoring model and highlighting the points. And then there's some new features here which have to do with equipment properties. And this is where you can bring data back from BIM 360 field back into the Revit environment, but you've got to go by Glue. So just to keep it simple, we're just going to focus on taking the data from Revit up to Glue. So we're gluing the model on the cloud. And what we have here is just a sample of the models that have been sent up. So in this case, I'm sending the model up from Revit. So there may be a structural engineer, a mechanical engineer, an electrical engineer, plumbing engineer, all these different people working on the projects. What they can do is they can glue the models separately to the cloud, and it will list all the models here within your glue interface. And then once you have the models you want to review, you can merge them together on the cloud. So that's gluing them together on BIM 360 Glue. On the right-hand side here as well, this is the real-time collaboration or coordination. We have activities. So all of these activities of people gluing models or maybe doing clash detections or reviewing can be tracked. Anybody who logs in can see what day and what time a user came into the model and did their particular tasks. What's really easy about Glue is it's got a very clean and simple interface. So over here on the left-hand side are the tools you need to navigate and perform tasks or activities on your models. And then on the right-hand side is your setup. So this is where you can go into your admin and a number of your settings to set up how you want to configure the model. So simple things like maybe changing the units from feet to meters, or displaying the graphics, or how you want to measure angles, etc. So very easy to get that going. And then once you're going, you have these tools on the left hand side of the screen here on this clean interface. So you can select any part of the model, read the properties of it. You've got measurement tools where you can read measurements from point to point or object to object. You've got a model selection tree. So this is where you can bring up a selection tree like you have within the Navisworks environment and see all the different types of properties or the components of that model, so the period and objects. You can do your markups. You've got a little pen tool here. You can create views, numerous views within the models. The recording of your activities, which you see on the splash screen when you start BIM 360 Glue. And of course, clash detection that will go through your model and check for any errors in the geometry. Attachments, this could be a PDF attachment or even a link to a URL. You can add attachments to certain properties of models. Sometimes when you bring up certain data, that information will be embedded in the model, and you can actually read these in tools like Navisworks and Glue. And then finally, exchange, and this is working with third-party applications, so you can start to exchange data with other company applications. So a quick screenshot of a navigation tool. So what you'll start to find is the navigation tools are very simple. They're the same as what you have within Navisworks. So we can turn on an avatar, and we can turn on our walk tool, and we can very quickly walk around that model. We can turn on gravity and collision and other walking tools to allow you to crouch and move through the model. And what you can do is when you've found a view within the model or found an item within the model that needs to be reviewed, you can say that in your views tool here. So in this case, a simple thing is like a connection detail for some of these structural components. What we can do is we can save out that view, and then we can use our markup tools to highlight the area that we're looking at, type in some notes, and then we can actually save that into a folder, and we can also notify several users. So maybe I want to send this out to several people in the team. It could be the steel fabricator, the structural engineer, and the architect. They all need to be aware of this detail that needs to be revised. I can instantly notify them, those team members. They can click on that link and via their web browser go straight into BIM 360 Glue to see the markup that I'm referring to. Again, here within the Activities tab, so if you want to see who's accessed the model, and maybe there might be email correspondence, you can go and click on any of these users. At the moment it's just myself. You can click on all of these envelopes to take you to the notifications and then information on what date and time these activities took place. And in this case, this was on the construction demo model, but you can also look at, say, the singular model, so the construction architecture model. The really powerful tool here is the ability to do clash detection. So if you're working on a healthcare project or a laboratory, something that's heavily serviced with a lot of electrical, gases, and mechanical components, you can run clash detection. So it doesn't have all the features that, say, Navisworks Manage has, but it has the features that you need to run a standard clash detection, and then you can go through the items that clash and choose to ignore or close or resolve them, and then you can add comments and assign them to users. So on the left-hand side we have our selection tree, and this is a clash between the architecture and the structure. I don't want to grab all the elements, I just want to grab certain elements in the model, otherwise you'll have hundreds or thousands of clashes. So in this case we're going to go through and set it up with a 50 or it could be a 20mm tolerance, and then we can run that clash detection and then go through some of these clashes and then choose if we need to mark them up, add some comments, and then notify several users about making changes. Or we can use some of these new tools like ignoring those certain clashes. So maybe they don't need to be resolved in the virtual world. They're a minor issue to resolve on site. So in this case, I've got an acoustic wall panel which can just be cut down on site. It's not a major issue because they come in certain preset sizes, clashing with a cellular beam. So in this case, I've gone through and I've chosen those clashes, and I've highlighted, say, those can be ignored. So there's all these tools that are coming into the cloud applications which allow you to configure how you want to see that information in your clash detection. Likewise, it works on a mobile device. So a majority of our tools all work for iPads and iPhones at the moment, and also some newer ones are coming out working on Android devices. So in this case, BIM 360 Glue for the iPad, it doesn't give you all the features as it does the web browser, but it does give you some features, again, to navigate around the model. So on the left-hand side, you've got this joystick, which allows you to walk around the model. You've got like a little gyro that you can hold down, and you can be standing inside the model and be spinning around inside a room. You've got a gravity tool here, and then you've got a home button. Down the bottom for interacting with the design, you've got your model selection tree graphics here, so you can select that and read parts of the model. You've got your views, so if you publish the model from Navisworks with a number of saved views, these views will transfer through, as does the Revit save views. So a lot of that data is coming through from your authoring tool up into BIM 360 Glue and being readable on the iPad. You also have a markup tool and a measurement tool, which I'll show in a second. So we can use our joystick to walk around the model, or we can go to some of the save views. And within the components of those models, so in this case this wash hand basin, I can start to read different information from the source file. So all of this intelligent building information modeling data is transferring through. It is readable on a mobile device while you're on site. These are the views, so you can go to your View tab, and some of the views that were set up within the Revit model. I don't need to use the joystick to navigate around. I can quickly have some basic views that are going to take me to the rooms that I need to look at on the cloud. So I can click any one of those and it will take me to the room for doing a markup. In this case, a simple thing is there's not enough handrailing in the model. This is actually an Inventor handrail design. So I'm going around, I'm inspecting the model, just doing the first run through that model, and there's some missing handrails. What we can quickly do is we can use our pen tool to do a markup. So all I'm doing is sketching out what the handrail needs to be, and then making a note, and then saving it out, and then I can actually notify users. So I can go back to the architect and say, well, look, you've left out a handrail here, we need to include it, and they'll get that message instantly. They can click on that link, go onto the model, and see the markup. Another great tool is measuring, just doing basic measurements. So you can measure point to point, but there's also a tool here just next to the measurement tool, next to the point to point, where you can go from object to object. So what it will do is it will take the shortest distance between two objects. So maybe it could be a clearance between a door frame, door panel. What you can do is you can click that and it will pick up that information. In this case, this is 2 elevator lift doors, and it's taken the shortest point between where the door retracts back to at being 0.4 of a meter. So handy little tools there that can help you measure information from that model without having to be too accurate to pinpoint. So moving into planning and logistics, I see there's a couple of questions that have come up. So what we'll do is we'll save this for the Q&A, but please keep adding the questions and we'll answer them the best we can at the end of the presentation. So moving to planning and logistics, this is where you can take your Revit data into Navisworks Simulate, and you can do your reviews, but you can also run construction logistics sequencing. So this is bringing in a Gantt chart where you can use it to drive the building of this model. So I'll just show you the workflow here. This is the Navisworks interface. For those who haven't seen it, it has the typical Autodesk ribbon interface. What you'll find on your Home tab is your core tools for working in the Navisworks environment. So this is the Navisworks Manage, and you can see you've got clash detection, timeliner, quantification, rendering, and also an animation and scripting and appearance profilers tools. So these are sort of your core tools, and then within the other tabs here are the tools to do things like reviews and run your animations and export stuff out. So one of the simple plays we have here is to be able to get the data and then configure it into manageable search steps. You don't want each individual component and have to go through and manually do this. So we've got this really powerful tool in the Find Items selection tool here, which allows you to go through and find all the information with certain properties inside your model. So one of the simple ones we've got here with that clicked is the ability to go and find all the metal piles inside of this model. So what we can do is we can go through this selection tool. We have categories, looking for the name of this component, the condition is going to be equals, and then we can go through our value selection and find the metal piles. And all we do is we go find all, and it will find all those metal piles in the model, and then we can save that search and save it into our search selection set. So perhaps during the design phase, a number of items might change. Maybe we need more piles, we need less piles, maybe there's another wing being added to the building. What you can do with this tool is when you reload that model back in, you can rerun that search, and again it's going to pick up and group all the piles for you. So it's a really powerful management tool to be able to capture that information without having to manually go through the model and do it yourself. So what we've done here is perhaps we want to be a bit more complex about what we're selecting. So we've got a lot of columns throughout our model, but we only want to get the columns, say, within a certain zone or on a certain level. So we can create our first category down here, which is our item name, and we're wanting to get the value of the universal columns, but we only want to get them for level 1. So again, you can create another property, and in this case we work with layers, which represent the levels in the model, and we can assign that to grabbing only the entry level or level 1 columns. And again, that intelligent find item tool will go through and find all those components on level 1. Now you could break this down into zones or certain wings, and again you'll be able to find that information instantly. So if you're doing an incredibly large healthcare project where there's a lot of components, this is an incredibly powerful tool to have for creating your search selection sets. So with these items defined, I've just done a basic search selection set here with all the components from the structural model. I've also done some basic selection sets without using the search tools, so you can do either or. And I'm using now the timeliner tool to look at construction logistics. So you can add tasks manually here. So if you have the names of all the components in your selection tree matching the task name, what you'll do is you'll be able to run and auto attach task. So just here you can actually run auto attach just next to the attach tool. And what this will do is it will automatically attach those selection sets. If the name matches, it will attach it directly to the model. So again, these are tools that you don't need to do this manually. You can actually use some of these automated tools to instantly match the geometry of the model to your construction program. Likewise, you can also import in your own data sources. So over here on the left-hand side, this is also here within the Timeliner tab here. It's just a close-up of it. We have data sources. You can go and add numerous data sources. So some of you may be using Primavera or Microsoft Project. CSV, of course, you can export that from an Excel spreadsheet. You can put together your construction program to match the setup in the Navisworks Timeliner, and then you can go and you can automatically map that information directly to the geometry. So you can bring this information in from a spreadsheet, from a Gantt chart, or you can do it within Navisworks as well. The choice is yours, but it's a great way because there's a lot of automated tasks that will map the information automatically. And from here, what we have is the result of our Timeliner animation. So when we've gone through and done our tasks, brought in our data sources, we can configure some of the graphical settings. So if you want to show, say, the lead into the slab's been poured, it will show us green before the activity starts. And then we can hit Simulate. And what this will do is it will run through that Gantt chart with the model components, and we'll run a construction animation. So down the bottom here is the data we've inputted, our selection and fine selection sets here on the left-hand side, and on the right-hand side is our Gantt chart showing different months of the year and different days within those months, and then when those activities start. And what that does is it drives a construction sequence animation of your model automatically. You don't need to be a visual expert or anything. This will automatically drive it. What you can do from here is you can also choose different camera views. So you can animate these camera views if you want to, or you could just be looking at certain camera views in the model. So say for your footings and your piles, you have one camera view, but maybe on the fourth floor where you're doing your dry lining works, you'll have another camera view, and you'll be able to look at the sequencing of events. And when you share this with other collaborators, it'll be able to enable discussion to see whether there's any logistical issues of building that. So you can be doing this in the virtual world, working it out prior to going out on site and then building it. So some big companies around the world like Lang O'Rourke doing the Leadenhall building use these tools on projects like the Leadenhall to build the building 37 times before they go to site. They want to make sure before they get out on site and start assembling all these building components that they've worked it out perfectly. So Navisworks Simulate is a perfect tool for doing this. Okay, so with all this data configured in the virtual world, we now want to move into how we take it into the field execution and then hand it over to a building owner for FM and operations and maintenance. So this is our BIM 360 field application. And this works with mobile devices. At the moment, a majority of applications works with iPads. There are some applications, some of our 123D applications where it's coming onto Android. But at the moment, it is based around the iPad. So this is going to be a quick overview, just a simple example of how we might use some of this data for hanging a door on a project, just to keep it simple. So what you'll do within BIM 360 Field is you're going to configure the library data. So this could be 2D PDF plans. It doesn't actually have to be a 3D model. You can send up 2D data. You can take your models from Revit, from Navisworks and BIM 360 Glue and actually put this on your field application, so you can actually have the model on your iPad when you're on site. You can put photos in your library, or you can capture photos on the field. So it could be photographs of issues that need to be corrected, you know, for defects or for snagging, or it could be issues, you know, just to record the quality of the installation. And also you can have all your PDF specification data. So in this case for the door, what I have loaded in the BIM 360 field database is a door installation guide. So I can have all this information here on my mobile device. I don't need to go back to a site hut. I don't need to go around with rolls of paper. It's all here on a small iPad at my fingertips, which I can look up. And instead of having to scroll through all the information on the iPad, what you have here is when it reads the PDF, you've got all your pages, but you can also search for items. So we've got a little search tool, and that little search tool, when you click on it, it will bring up a search, and you could be looking for a certain feature within that door. So door handle installation, or doing locks, or just basically hanging a door with hinges. All of that information can be searched for, and it will take you to the page on how to guide you through the installation. So what we have is we will configure the BIM information data on BIM 360 field via the web browser interface. You've got to get this set up before you go out to site. So every project is going to be different. On a healthcare project, it's going to be require a bit more setup time than, say, an office project. You've got to set it up based on the data you want to use further downstream, and it's a good idea to put everything in folders and give everything correct names. So once you've done this within the BIM 360 field database through the web browser, you can now sync this data to your iPad. And I've seen just one of the questions about having a constant connection to the cloud. You don't. You can actually go out with BIM 360 field and you're not connected to the cloud. So I can sync it to my iPad that doesn't have a SIM card, and I can go out in the field and capture a huge amount of information. So I just sync down the information from my web browser. It's embedded on my iPad. I go out on site, I take photographs, I do markups of models, I record issues, I go through the tasks and the checklist for QA/QC, and then when I get back to my office, I can go down to the bottom here, and there's a little sync button. And what you can do is when you're within your office's Wi-Fi, within the firewall, I can sync that information. That's going to sync back via the Wi-Fi and go back to the BIM 360 field database. So a quick workflow here. It's a very simple workflow. What we could do as a follow-up for this webinar, we could do maybe a more detailed one on this application, because there's quite a lot to get through. What we can do here is we can navigate through our model. So it could be via the 3D model that we get from Glue, or it could be via the 2D PDF plans. And we can go to a location on our model, which is at the entrance of our model. We're looking at a grilled double door. And we can go through different types of tasks. So the main contractor could set up tasks for the subcontractor to go and fill out, and they can go through and they can run through these tasks. So in this case, we're going through and we can see there's attachments and comments and different types of issues we're going through. In this case, this was going through a punch list. What you can also do before going through the punch list to do your defects is you can go through checklists. So when you first get into BIM 360 field, there's a number of sample checklists already configured which you can use, or you can download Excel documents to configure them for your own office setup. So in this case, I'm just using some basic checklists. So I'm going through, I've been assigned a task to go out and install a door, and there's a few checklists I need to go through before I do it. So all of this information can be hosted in my checklist, and I can go through and customize it. I can go through and do all these checks for door closers, lock sets and latches as I go through this installation. So during this installation, these are the checklists that have been allocated for me to check. So I'm going to hang the door, but I need to ensure that maybe the storage of the door is correct. When it comes to site, I need to check the jams. All of this information you can go through and you can sign off whether it was done, whether it wasn't done. Maybe you turn up and the doors haven't been stored correctly, you know, they've been waterlogged or something. You can go through this checklist and you can fill this out, and then what happens is this information is going to go back to the cloud, and the main contractor is going to see this information. So we're on site, we're taking some photographs as well. So in this case, we've got some photographs of the door stays. we're maybe even doing a little red pen markup here of the doors that we're fitting out on site. And we can even have a link to the door supplier or the door manufacturer. So there's a lot of different configurations. So this could be used not just for a door, it could be for something more complex like a pump in a plant room. All of this information can be embedded and you can have it on site for going through this installation and checklists. So we can go through this, and then this is just a draft one, just a quick snapshot of some of the issues that have gone through while we're on site. You can see here there's some of the checklists shown. So this is a draft one for rail construction. What we can do is we can move through the process. So we can put this little push pin in our model. We can do it in plan, or we can do it within the 3D model. And we can assign whether something is completed, so it's ready to be inspected. The person who's inspecting it could go back and make a notification saying it hasn't been approved or there's a dispute, and then these push pins are going to change color. So if you're going through the model and you see all these push pins, there could be several of them that are red that just drafts. But if we look up a little bit higher here for the steel contractor, they've got a yellow push pin, which means it's in dispute. So there's a lot of graphical displays here which allow people to see what items have been completed, inspected, approved, or closed out. And of course all the attachments and comments. So when we're on site and we're capturing site photographs, or we're looking at a PDF document on how to install, that's all there within this capture. And then finally, with all this information captured, it doesn't just have to sit on the cloud. You can download this to your own database. So let's say you're going to have glue or field for a certain amount of months, maybe 6 months for the construction duration, but you want to capture that information and keep it for a later date, because once you've stopped using these tools for a certain amount of time, you won't have access to the cloud anymore, but you can still capture all the reporting information. So it could be PDFs of drawing markups, but also the information on the status of these doors here. So if you see in our Excel spreadsheet, this is the doors, some of the items we've gone through, we can report on it, and then it's got a number of parameters that we can report on that were conducted on site. So the great thing is, even if you're not on the cloud 6 months or 6 years from now, you still have the ability to download those field reports. Likewise, you can also bring the data from the field back to your authoring model. So earlier I showed some information on equipment properties for BIM 360. What we can do here is for this particular door, we can capture the information on the field and we can sync it back through BIM 360 Glue back to Revit, and we can read the information of what happened on site. So there's a lot of information here in the properties for this grille double door that have been read, have been captured on site, like the checklists, the as-built information, open issues. All of this data that we capture on site can be read back within the authoring tool. So for those of you who may be working on university projects where they're consistently extending or building new parts of the campus, they want to have as-built models. So when they come to extend or refurb or do something different in that building or recondition it, you've actually got the data that was conducted for the as-built embedded back within the authoring model. So this is a fantastic round-the-world workflow which allows users to capture information while they're on site and then take it back to the authoring process for use further down the track, say 10, 20, 30, 60 years later. Okay, so up on point layout. This is for the surveyors who want to be able to take data from the authoring model out to the site and then back from the site when they do the when they're working with the total stations and working out the different levels. They can take their data back from the total station via BIM 360 Field and Glue back into the Revit environment. So in this case, we're going to look at a couple of workflows here for point layout and being able to transfer the data via BIM 360 Field. So a basic workflow here looking at a slab. So when you get Autodesk point layout, we'll call it APL, what you'll have is an add-in that will sit within Revit And this add-in will give you some pretty cool features that allow you to go through and automatically create control points, tag them, assign them to walls, to ceilings, to faces. You can export and import this data either via field or you can do it via CSV files. You can also use some of the other advanced tools which allow you to look at deflections and slabs. So I'll just go through one of the basic workouts here where we want to add points to our slab. So with the points tool selected, we can go through and add these building control points. So you can add a point prefix if you want to that information, and you can go and place it on particular points in your model, or you can actually go and do it automatically by grid. So like the divide and parts tools, you can use some of the grid tools to control where these points go. Once those control points are placed over here on the left-hand side, we have the information for those control points. So automatically it's given it a number, and we could actually add a prefix, and that will go in front of that number. So that's added the points within our model. It's populated it with its XYZ coordinates. So in this case, it's set up as an offset of 3,800, so it's the Z value, and it's sitting within the X and Y coordinates within that model. Next, we can also go through and we can tag the components. So there's an automated tagging process where you can tag all the points, and you can add leaders as well. So there's different variations you can add. You can add a spot elevation or a spot coordinate or a tag, and it will go through and it will grab the information that you need if you want to do the whole model, or you could fence off part of it. And in this case, we're just adjusting some of our leaders, and we can also add more information to that point number. So we can afterwards add a prefix of L2, so it's on level 2, and that can be realized in the tag. Another way to do this is to actually do it in the family of Revit. So for those of you new to Revit, it's parametric modeling of objects, a lot of intelligence in these objects. These are the families. And what you can do is you can open up something, a simple family, which would be these metal piles with pile caps. We may want to have a control point on the center of those pile caps. So what we can do is we can open up that family. We still have access to the point layout tools, and we can add a point to the center of that pile cap. And then when we bring it back into our Revit environment, our Revit project environment, and go and tag it all, I don't need to manually place those points. They're always going to read at the center of those pile caps. So there's several ways you can go and populate the control points within your model. Additionally, you can do this with walls as well. So you saw on the first slide of the point layout part, you can do like faces and walls and different parts of the model. So in this case, we want to use the wall tool, and we can go through, and by default, I've just chosen the edges of the walls and also the center lines of the walls. And I've added a prefix in this case, and given it a start number of 3,000 because it might be on level 3, for example. So what we can do is we can go and use this add wall family points tool, and we can populate the wall. So we can select maybe one wall or several walls, and then instantly get points around that wall and then have it tagged. And again, you can see here on the left-hand side of my screen in the properties, it's got the prefix embedded within the properties of that control point. So this information can be transferred out to a USB station, to a total station via a USB file or via BIM 360 field, which I'll show in just one second. The other thing you can do here is you can use this slab analysis tool as well. So you could be outside with your total station, you could capture information on the slab, and then bring that CSV file back into Revit, back via the point layout tool. So what we can do is we can click on this slab analysis tool. It's up in the top right-hand corner here. And this will bring up on the left-hand side the file to import. So all I need to do here is select the file to import, the CSV file, or I could actually go to import from BIM 360 field, which I don't have configured at the moment. But if I just use the CSV file, it's going to bring in all the site information. So all these different X, Y, Z points can be imported back into our our Revit model, and I'll just say that the point roll is going to be as built, and then we can get a graphical overlay here of the points of the slab and look at any face deviations. So this is a very rough way of doing it, just for this particular demo, but you can go and customize all of this, and you can bring the information of the as-built data back into the authoring model via Autodesk point layout. So there's a couple of ways to take the data through. So number one is transferring it to the total station via a digital file transfer or a USB. So we can go through the BIM 360 field workflow, and we can take that data out to the total station. So this is just this is the file to compare. So we have a CSV file. Maybe we want to do compare the field data versus the actual design intent model or the design model to provide a QA/QC report. So all this information can go via the BIM 360 field, and here's the splash screen of this information. So it's via Valor, which used to be the name of BIM 360 field. And we can integrate this via 360 field and provide the QA/QC report directly from Autodesk point layout within Revit directly to BIM 360 field. And then what we can do is we can import those field locations back into Revit. So in this case, we're looking at moving just the model points. So we can use an option one here, move the model points to the new field location, and this includes the ability to move the Revit families around as well, so the piers and columns. And then option secondary as-built point for the field location. So one could be slightly out, so you can see here we've got 101.44 for the design intent model, and then we've added a suffix to the end of that 101.44 for the as-built. So it may be just slightly out for the as-built, but we've got this accurate field data which we can bring back into the authoring model. So again, it's another great way to capture as-built information and bring it back into your design model to review. Okay, so just to finish up here, so today we've gone over Revit construction modeling, some of the Navisworks construction simulation tools. You just saw point layout and some of the integration with BIM 360 field. And we had BIM 360 glue for some clash detection and BIM 360 field for a door on-site field management workflow. So I'm now going to go through some of the questions and do my best to answer them. So we've got half a dozen questions here in our dialog box. For anybody new to using webinars, there's a question tab. You just extend the question tab and you can start to type stuff in that question box. So question one from Neil Scott. Do you see Australia taking this design approach of working with the contractor? So I presume you're talking about the design and build procurement where the contractor's there on day one. That's what I saw a lot in the UK. I think it could catch on here. It just depends on how it's sort of managed. It's sort of a double-edged sword because sometimes it can affect design quality, but for the building owners, you're going to get your building built a lot more accurately on time and on budget, which is kind of a crucial thing. What we are starting to see here in Australia in terms of contractors utilizing more of the BIM data is companies like Hanson Yuncken and Langer O'Rourke, who are already using BIM 360 field to actually manage that data on site. So I think the contractors are taking a more proactive role with wanting to utilize that data. The other question from Neil, I see a problem with someone making a change that does not understand how that may impact the overall design. So this is making a change within the Revit model or a change within the Glue or Navisworks model. What you can do, for example, if you're making a change on the field, you're not changing any of the geometry. You're just changing, say, something like a performance spec. So, for example, the door has to be a door with a grill in it, and the grill has to allow a certain percentage of airflow. In the UK, the contractors would typically look at the architect spec and find a cheaper door which does the same, and they just swap it out. The geometry and the measurements would typically be the same, but maybe the door spec is different, so that can be captured on the field, and then that data can go back into the Revit model. So it's still a door, but it's just got some slightly different properties within it. So just going back to the questions in the list, and I will come back to you in a second, Neil. So from Chris Stadden, BIM 360 Glue, does an iPad require a constant connection to the cloud? So the answer to that is no, you don't. You can just sync all the data, so it's embedded on your iPad or cached to your iPad. Can our site team download the model from the cloud? Yes, in the site office. And then, yeah, exactly. So you can have all that data synced to your iPad, and you can go out on site and work with it, capture more information on the site, and then sync it back to the cloud once you're in the site office. Okay, another question from Chris. So this, I presume this is on Autodesk point layout. So placing points for the purpose of a slab penetration. Yeah, exactly. So my background is architecture. We do have a specialist in our office who could probably explain this in a bit more detail for point layout, but in essence, yeah, you can put points anywhere within your model and set them up to different locations, and you can do penetrations in the slab if you want, and then go out, set them out, put in your formwork, and then record that information, then take that back into your Revit data and see if the opening in that slab is being set out in the right location. Okay, so Neil's got another question on advantage to the style. So in terms of the style of design and build, there is an advantage for building owners, I think, and probably for contractors. There's kind of a fine line. The projects that I was involved with, there was a couple with, one with Balfour Beatty, one with Langer O'Rourke. So for schools, Balfour Beatty wanted to avoid a lot of curves because they cost money, and they take a long time to get right, and they could delay the construction process. So they were very adamant about what the architects would design. However, if the architects didn't do decent designs with curves, then they would be criticized by the public or by the users of that space. So it kind of goes both ways. It is, it's a great workflow for contractors because it's going to make their lives easier once they get out to site. Potentially, if you avoid things like curves, it's going to be less waste, so you're going to go better into lean construction. Another example is Langer O'Rourke. They have a factory called Explore just north of London. What we were having to do for healthcare projects was build the model as prefabricated concrete parts to work exactly with their fabrication factory, Explore. So it made it a little more difficult in terms of planning the design and dealing with getting planning permission as well, because we had to work with a Lego set. But when it came to reusing the data for fabrication, it was fantastic because you could put it into Langer O'Rourke's CNC system, and it would spit out the concrete panels. And of course, when it comes to building it, you're going to be able to build it a lot quicker on site with the precast components as opposed to doing in situ. Okay, and then finally, is the 360 controlled by US internet data capture? So this is talking about where it's hosted. It is hosted in the States at the moment. Yeah, so it is hosted in the US. What we do with a lot of our cloud technologies is we use Amazon. So it's AWS, Amazon's web services. So it's the EC2 data centers, and there are data centers being done here in Australia, which I believe we're going to be starting to use, because I understand there are certain conditions with contracts so contracts with your clients, you can't move data offshore. So yeah, there are steps being taken to have data centers here on Australian soil, so they'll be hosted here in Australia. Okay, so for Neil and Chris, thank you very much for the questions. I hope I've answered them. What you can do is, if you could provide some feedback to A2K, they have their email address here, or you can contact your account manager. If you want to see a more detailed, deeper dive on, say, point layout, or some more on BIM glue and field, please drop us an email, and we'll be happy to come to your office and do a more in-depth, hopefully a face-to-face demonstration. But this is just a starting point, and thank you very much for attending today. I hope this helps you in the future with your workflows, and I would encourage you to get in touch with your account manager, and we can come out and do a more in-depth, detailed workflow on some of those products we just discussed. Okay, thanks very much, guys. So if there's no more questions, we will end it here. Megan, do you have anything to add?
Well, no, thank you very much for that, Samuel, and we'll have this webinar available on the webinar vault later next week. Have a great day, everyone.
Thanks very much, guys. Thank you.